All right, this problem is so cool, it's going to take a long time. Are you ready for the most difficult word problem you've ever seen in your life? Here we go. The boardwalk is parallel to and 210 feet inland from a shoreline. So we've got, water out here. Yeah, whatever. So this is 210. Okay. This reminds me of a trip to South Carolina this summer. You have these boardwalks so that you don't have to walk through the sand the entire time. Because sometimes we were walking through the sand, then you get like sand in your shoes, and it's just a pain. And sand, like by the ocean, is really really fine sand a lot of times, and that fine sand it just makes its way in the house and everything else. It's just a pain in the butt. Okay, so boardwalk is parallel to and 210 feet inland from a straight shoreline. Sandy beach lies between the boardwalk and the shoreline. A man is standing on the boardwalk. Okay, he's standing right there. And he's exactly 750 feet across the sand from his beach umbrella. We're gonna, you know what? We're gonna put a shark in the water as well. These problems are always more interesting if there's sharks involved. If there's a possibility of death, probably take it more seriously, right? So he's 750 feet from that spot. So the question is, if he walks 4 feet per second on the boardwalk and 2 feet per second on the sand, how far should he walk on the boardwalk before he veers off and goes on the sand if he wants to get to his umbrella in exactly 4 minutes and 45 seconds? Let's admit that the problem's stupid to begin with, right? Like, why would he care? No. The deal is we could set this problem up a different way. We could say, how far should he walk on the boardwalk before veering off in order to get to his umbrella as quickly as possible? Like, that's a better question, right? Because the problem is we don't know how to solve that kind of a problem yet. We have to know the time. So you're going to revisit this problem in a few weeks, like a month. Okay, and we'll come back to it. Here's a different question. Who's a lifeguard here? Okay, how many lives did you save last year? None? You still got paid? That's ridiculous. You're a lifeguard and you didn't save any lives, you still got paid. You? 5 lives. Look at that. That's yeah, exactly. All right. So when I was a lifeguard, sometimes I would just blow the whistle and I'd point somebody and say, I'm coming in. I'm saving you. You know what I mean? Just to have a little fun. Otherwise, you just sit there the whole time. It's like, let's practice. Like, pretend like you're drowning. I'm getting bored. You know what I mean? And then it's just a good time every once in a while. So here's a great question. You look out, and there, in the middle of the water, somebody is drowning. So do you jump in the water right away, or do you run along the shore for a little ways? Well, at what point do you enter the water then to try to get to the person as quickly as possible before they drown? So my point is that studying these type of problems can really pay off. Now, we're trying to talk about situations. Obviously, the lifeguard wouldn't sit and try to figure that out before they actually save the person. But a general rule of thumb, okay, maybe you run halfway and then enter in. A general rule might, every second matters, right? So yeah. Way to go, Mr. Lifesaver, man. Okay. Does everybody agree this is a distance, rate, time problem? So that means that rate is equal to distance divided by time. We know in this problem that we are given a certain amount of time. And I'm going to say that the time on the boardwalk plus the time on the sand should be equal to how many seconds? 285 seconds. How'd you get that, smart man? 4 times 60 is 240 plus 45 is 285. Well, it looks like if I need to know time, I should write an equation that involves time. So I have rate times time is equal to distance. So time is equal to distance divided by rate. All right, well, I need the distance on the boardwalk divided by the rate. What's the rate on the boardwalk? 4. Let's see. Distance on the sand, I don't know that, but the rate on the sand is 2. So it looks like I'm pretty close setting this up. I just need a distance on the boardwalk and distance on the sand. Well, I'm going to try to help you out a little bit. We're going to call this X, but I want somebody to give me something that's intelligent here. I mean, I need to know what S is, distance on the sand, and I need to know what B is, the distance on the boardwalk. And I will give you a hint. You can write S so that it's an equation that has X in it. And you can write B so that's an equation that has X in it as well. Can anybody give me anything intelligent? Pythagorean theorem. Tell me more. Okay, I like what you're saying. So here's what we have. 210 squared plus, we'll call z squared, is equal to 750 squared. We'll say that z is the entire distance on the bottom. So we could solve that. Take out my handy dandy calculator. 750 squared minus 210 squared. 518,000. Square root. Did you guys know this option, square root? I don't have to type 518,400. I can just go second, the negative sign. ANS means answer. Takes your previous answer. Did you know that? He knew it. What are you doing, Carson? Watching my videos? Trying to steal all my tricks? So that entire distance is 720. If that entire distance is 720, you can. Let's get back to that. But first, if the entire distance is 720 and this is x, then we could write b is 720 minus x. Very good. So distance on the boardwalk is 720 minus x. Thank you. Now, Jack has a really good idea. Jack is saying that x squared plus 210 squared is s squared. Agreed? So I'm going to write that. X squared plus 210 squared is equal to s squared. So if I then square root, I get s is the square root of x squared plus 210 squared. So now we know the distance on the sand is the square root of x squared plus 210 squared. Nice. What do you think? That's our equation. You guys, every other single problem we've had, we set it up, and then you're like, oh, I can solve the equation. You see that one. Are you confident you can solve that equation? We're kind of at that point, folks, where we're supposed to be experts in algebra. If you see an equation, you want to say, yeah, I can solve any equation you give to me. And so I'll help you solve the equation, but this is one hopefully you can do. I'm going to get rid of the fractions by multiplying by 4. Question. Excellent point. Let's look at that right now really quick. Square root of, I'm going to try this, 3 squared plus 4 squared. Okay, what is 3 squared? 9. What's 4 squared? 9 plus 16. So you get, everybody agree you get 5? Watch what happens if you just get rid of these squareds here, okay? You get the square root of 3 plus 4, which is the square root of 7. Are those two the same? So let's look at where you can get rid of square roots underneath. Square root of 2 squared times 3 squared. If it's multiplication, let's see what happens there. 2 squared is 4, 3 squared is 9. Multiply those together, you get 36. And the square root of 36 is 6. Is that the same thing as if you do the square root, get rid of the squared, so you'd have 2 times 3 is 6? Does that work now? Yeah, if you have multiplication, then it works to do that. But here you got addition. You cannot do that in that situation. Good? Okay. All right. Multiply through by 4. I get 720 minus x plus, now 4 divided by 2. So I'm going to have 2 times the square root of x squared plus 210 squared. 4 times 285. And you're fast, Alex. What's your middle name? Alex Paul. Sounds very astute. Mature. Intellectual. Lee. Kevin Lee. All right. I'm going to subtract the 720 over, and I'm going to add the x over. So I get 2 roots of x squared plus 210 squared is equal to 1440 minus 720, 420. And I got to add x onto that. Can anybody tell me why I just did that? What am I trying to do next? What am I setting myself up for? To square both sides. I don't want to square something with an x on this side. I want the square root to really be by itself. Now, some of you want to divide the two. That's optional. I don't really want to have a fraction over here. So I'm going to square this, and when I do, that 2 will just become a 4. So I'm going to square this. So when I do, I get 4x squared, because that 4 will distribute to each term. Plus, and then I have 4 times 210 squared. See, 4 times 210 squared, 176,400. $420 squared. Oh, 176,400. I like that. What's going to be in the middle? 840. Plus x squared. Oh boy, oh boy, oh boy. What now? Yeah, get everything on one side. So over here, we're going to have 3x squared. So now the x squareds are gone. Now what? Yeah, the 176,400s, those go away, right? Minus 840x equals cero, which is Spanish for 0. Does that factor? Yeah. Take out a 3x, and you have to x minus 280. Suppose it didn't factor, what would you do? Quadratic formula, just get out your calculator, type it in. You got a program, right? So here we got x is 0 or 280. What the heck does that even mean? Yeah, that's what x is. X is 0 or 280. Well, the original question was, how far should he walk on the boardwalk before he veers off? Well, he should walk 720 minus x, or 720 minus 0, which is 720 feet. Or, suppose you walk 280 feet on the boardwalk. 720 minus 280, 440 feet. That'll get him there in exactly